So today we're going to cover chapter 10, section 5. Today we're going to see angle relationships in circles. So the first one is called the tangent and intersected chord theorem. And this one states that if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So in this particular picture, A is the point of tangency here. So my tangent is down here. I'll highlight it in purple and pink. So this is my tangent. And this is the chord. And when a tangent and a chord intersect, then the angle that is formed, like for example, angle 1 here, it's going to be 1/2 of its intercepted arc. So let's say I told you that this intercepted arc, or arc AB, was 100. Then to find the measure of angle 1, all we would do is take 1/2 of 100, and angle 1 would be 50. Now, if you notice, angle 1 and 2 together, they're sitting on a straight line. So if you don't want to multiply by 1/2, you could also do 100 divide by 2. You get the same answer. Now notice angles 1 and 2, they're sitting on a straight line, that tangent line, and they're going to be supplements. So what you can do here is the easiest way to find angle 2 would just be to do 180 minus 50, and angle 2 would be 30. However, if they had given us the measure of arc ABC or ACB, then this arc would actually be 260, because remember the whole circle is 360. So then to find the measure of angle 2, we could do 260 times 1/2, and we get 130 that way as well. Same way that I just did, indicating that they were supplements. The next theorem is called angles inside the circle theorem, and this one states that if two chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Now, these two angles are not central angles. They are not at the center. So to me, what this looks like is that these are two angles that are floating inside the circle. So it looks like they're floating angles to me. They're just floating inside the circle. So for example, if I wanted to find the measure of angle 1, what I would need to do is take its intercepted arc, which would be CD, and add it to AB, and then either multiply it by 1/2 or divide by 2. So let's say I told you that arc CD equaled 80, and arc AB would equal 40. Then to find the measure of angle 1, I'm just going to take DC, which is 80, add that to AB, which is 40, and then divide it by 2 or do 1/2, 80 plus 40, either way, and angle 1 will be 120 divided by 2, and it would be 60 degrees. Now, this other angle over here is also 60 because they're vertical. But notice their intercepted arcs are different because they're not central angles. Now, again, the easiest way to find the measure of angle 2, notice these two are sitting on this straight line, so they would be supplements. So I could just do 180 minus 60, and then angle 2 would be 120. Now, if I knew something about its intercepted arcs, I could find angle 2 that way as well. But I don't know anything about the arc measures for AD or BC yet. This theorem is called angles outside the circle theorem. And all of the angles are going to be, the outside angle is this angle 1 in each picture. Now, we have 3 different scenarios here. The first picture here on the far left, this is a picture of 2 secants forming that outside angle 1. Then the second picture, this is a picture of 2 tangents that are forming the outside angle. And then the last one is a picture of a tangent, which is here, and a secant. And they're together intersecting and forming the outside angle 1. So what we're going to do is we're going to take their two intercepted arcs and subtract them. So instead of using x and y's, what I like to refer to as this piece of the arc that is furthest from the angle, which they've called x, I'm going to call this piece my big arc. So the x in this picture, or all the red, these are my big arcs. It's the bigger piece of the arc of the circle. And then this little piece, the arc that's closer to that outside angle, I'm going to call this little arc. And then the same thing here, little arc here. And it's closer to the angle. That'll be the arc that's closer. And this is little. So what I'm going to do instead is I'm going to say the outside angle, which in this picture, it's angle 1, is going to equal 1/2 big arc minus little arc. Now you could also do big minus little, so big arc minus little arc, and then divide by 2 instead of 1/2. So you could do it either way. So the bigger arc will be the arc that is farthest from the outside angle, subtract the arc that's closer to the angle, and then multiply by 1/2 or divide by 2. Or you can memorize the formula there with the x's and the y's. It's up to you. However, all three scenarios use the same formula. The next is a definition. And the definition, the vocab word is circumscribed angle. And a circumscribed angle is an angle whose sides are tangent to a circle. So in this particular picture, my circumscribed angle is this angle right here. It's angle ABC, or you could go in reverse, CBA. That is where the circumscribed angle is located. It's also that outside angle that's formed by the two tangents. The next slide has how to calculate the measure of a circumscribed angle, and it's presented as a theorem. So the circumscribed angle theorem states that the measure of a circumscribed angle is equal to 180 minus the measure of the central angle that intercepts the same arc. So in this particular picture, the 80B is my circumscribed angle. So that's the circumscribed angle, and it's located right here. The central angle that they're referring to is this angle here, the ACB, because the arc that they both intercept is arc AB. So you'll be given a measure of either the circumscribed angle or the central angle, and then you're going to ask to find different pieces or different arc measures. Okay, so here's our first example, and they're telling us that UT is tangent to the circle. Now, also in the picture, US is a secant. So US is secant, and UT is tangent. So notice this angle up here is the outside angle. So in order to find the measure of arc WT, which is right here, for part A, what I'm going to be doing is I'm going to be finding my outside angle is equal to my big arc, which is going to be over here, So big arc minus little arc, which is the WT, and then divide by 2. So let's fill in what we know. So my outside angle is the 30-degree angle. My big arc, this is big arc, it's 100. My little arc, I'm going to call this X. It's the WT. So this will be little. And then this 30 is the outside angle. So let's fill it in. So minus X, divide by 2. So here is where your algebra is going to come in. So we're going to go ahead and multiply both sides by 2 to clear the fraction. Now when you're multiplying this right side, all it's doing is clearing that fraction. You're not distributing the 2 to the 100 into the X. But you do have to multiply the 30 and the 2. That'll give you 60. And now I'm going to solve by subtracting 100. Negative 40 equals negative X. And now I have to divide by negative 1. And X equals 40. And remember, we said X was little arc. So my little arc was what they asked me to find. And it was arc WT. So 40 degrees is the answer to part A. Now let's go ahead and take a look at where angle TVS is located. So angle TVS is this angle right here. And notice this looks like it's one of those floating angles. So for part B, I'm going to use my floating angles theorem. This is just what I call it. So floating angles. Okay, so what I'm going to do for the floating angles theorem, remember we're going to take its intercepted arc. So its intercepted arc is, we're going to take its intercepted arc, which is ST, add it to its vertical angles intercepted arc, which is going to be this one over here, the WT, or the WR, or RW, and then divide it by 2, and that's going to give me the measure of TVS. So the arc measure for ST was 100. The arc measure for WR or RW was 110. I'm going to add those and then divide by 2. I get 210, divide by 2, and I get 105 degrees for the measure of angle TVS. So this one is 105. Now for part C, we've got this angle over here now, and they want us to find RVS, and RVS is over here. But if you notice in the picture here, both of these angles are sitting on a straight line. So the easiest way to find RVS is take the angle we just found and do 180 minus 105, because there's supplements, and that'll give me RVS. So 75 degrees is equal to angle RVS. And then the last part, they want me to find arc RS. Well, arc RS is right here. And if you look at your picture, we've already found, or we already have, all the pieces of the arc except for that one. So probably the easiest way to find RS would be to add 110, the 40, and the 100, and then subtract it from 360. So for part D, you could do 40 plus 110 plus 100. You'll get 250. Subtract that from 360. And the measure of arc, RS, is 110. Now, we could have also used our floating angles. And let me show you how we could have done that. So remember, this is 75. So another way to do part D would be to use the floating angles. There's multiple ways to do these problems. So what I could have done is I could have taken its intercepted arc, which I didn't know, plus the intercepted arc of its vertical angle, which was the 40, divide it by 2, and set it equal to 75. Then multiply both sides by 2 to clear the fraction. And then I get x plus 40 equals 150. Subtract 40. And x, which was my RS, 110. So same answer I got by doing it with a different technique. So there'll be multiple ways to do these. You just need to show your work and what method you used. All right, let's do this one. Notice this is a picture. This is two tangents. Now, this technique that I'm going to show you will only work for finding this outside angle, angle D here, when it's two tangents. Because if you notice, these two tangents are splitting the circle, and my little arc is right here. But notice my big arc, it comes up to meet it. So it's actually splitting it, not equally, but we could find one of the arcs if we knew part of the other one. So since I know arc AB, they gave it to me, it's 105. I know I can find the big arc, so this is little arc. To find big arc, all I need to do is 360 minus my little arc, and my big arc is going to be 255 degrees. So now I can do the formula. My outside angle, which will be the purple one, which is angle D here, is going to be equal to my big arc minus my little arc, and either multiply that by 1/2, or I like to divide by 2. So big arc, 255, little arc, 105, and then divide by 2. So 255 minus 105 is going to be 150. 150 divided by 2, and angle D is 75 degrees. This technique of finding the other arc measure only works when you have two tangents forming that exterior angle or that outside angle. You can't do it with two secants, and you can't do it with a secant and a tangent. Okay, so this one, they want us to find the measurement of arc AB. So arc AB, that's going to be my big arc. So this will be big arc. My little arc, they gave me, it's right here, it's the 20. So this will be little arc. And then my outside angle is going to be this angle 10 here, or the 10 degrees. So this is my outside angle. So again, same formula I just did. It's going to be outside angle is equal to big arc minus little arc, divide by 2. So let's fill in our numbers. We know the outside angle is 10. I know big arc. I don't know big arc. I'm going to call big arc X. And I know little arc is 20. And then divide by 2. Nice algebraic equation here. We're going to go ahead and multiply both sides by 2. That will clear the fraction. And then I have to do 10 times 2 and get 20. And now I have x minus 20 to solve for x. Add 20. And x equals 40. And remember, x was my arc AB that they wanted me to find. So 40 degrees. So the last one wants us to find the value of x. And x, this angle that's here, this is a circumscribed angle. Now, you could also recognize that these are two tangents. We could also use that knowledge and do big arc minus little arc, divide by 2. But I'm going to use the circumscribed angle theorem. So I know that this circumscribed angle is going to be angle ADB, and it's going to be equal to 180 minus this central angle, that's the 135.
And then you get x.
And that'll give you x. So I'm going to subtract 135 because this will be the measure of angle ACB. This is the central angle with the same intercepted arc. So the arc that they both share is this arc AB. So then all I need to do, and ADB was x, so 180 minus 135, and x equals 45 degrees. And I use the circumscribed angle theorem. Okay, so back at the beginning of the chapter, we learned the definition of a central angle. And remember, a central angle has its vertex at the center. So if I put a center point here, draw in 2 radii, it's formed by 2 radii. And let's say I call this angle, the central angle ABC. Remember, its intercepted arc, the arc AC, is going to be equal. So if I told you this angle is 60, then its intercepted arc would also be 60. This is when you have a central angle. The next type of angle we saw was an inscribed angle. And that's when its vertex is on the side of the circle and it's formed by 2 chords. Let's say it's A, B, C here. This is an example of an inscribed angle. And this one has its vertex on the circle. So for this, let's say I told you that the arc measure was 60, then its angle is going to be half of that. It would be 30. So angle ABC will equal half, or the arc measure divided by 2. Then we also saw the scenario where we have the intersection of a tangent and a radius. And this is where we did Pythagorean theorem a lot. So let's say I have a radius and a tangent. Know that when a tangent and a radius intersect, they form perpendicular lines. So AB here would be perpendicular to BC. Today, we learned about a tangent and a chord. So this was over here, the blue one was a tangent and a radius. Now we're going to see a tangent and a chord today. That's what we already saw. So if I draw my circle here and I draw my tangent, and then I draw a chord. So this is A and B. Then we learn that if I put a little 1 here, and then I tell you this arc here is 100, we learn that the measure of the angle formed by the tangent and the chord is going to be half of its arc measure. So when it's a tangent and a chord, angle 1 here would be 1/2 the measure of arc AB. So here, since arc AB was 100, angle 1 would equal 50. Then we also saw today the floating angles. So if I have my circle, and then I draw in 2 chords, C, D, A, B, and I ask you to find the measure of angle 1. So this is the floating angles. So let's say I told you that AB was 60 and CD was 40. To find the measure of angle 1, we would add arc AB plus arc CD, divide by 2 or multiply by 1/2. So in this case, I would do 60 plus 40 divide by 2. This would give me 100 divide by 2, and angle 1, that floating angle, would be 50 degrees. Then we saw the 3 scenarios with either the 2 tangents, tangent and a secant, or 2 secants, and what that created. So we had and then we have another circle, and then let me draw one more. So this was the 3 scenarios, all using the same formula. So we either have 2 secants, we have a tangent and a secant, or 2 tangents. And then they're all forming this outside angle 1. And then here is where we would do our big arcs minus our little arcs. And remember, the little arc is closest to that outside angle. So again, our outside angle is formed by doing big arc minus little arc divide by 2 or multiply by 1/2. And then the last was the circumscribed angle. So a circumscribed angle is formed by 2 tangents. So if I add in variables here, B and D. So this is going to be the circumscribed angle. Which is going to be angle D here. So angle D is just going to be 180 minus the central angle with the same intercepted arc. And that central angle is going to be this angle ABC, because they both share this arc right here. So in other words, it'll be angle D equals 180 minus angle ABC. So a nice little summary of everything that we've covered so far, and you may need to apply all of this in order to do tonight's homework.